Hola a todos, soy Javier Poveda y esto es Debian TV, el canal donde te lo vas a pasar de bine, que dirían los rumanos, mientras aprendes geografía, historia del arte y este año una pizquita de economía y de empresariales. Este vídeo va dirigido a mis alumnos de primero de la ESO de sección del CEIPSO el Encinar de Torrelodones. In this video we are going to study Unit 4, Weather and Climate. So let's jump to our presentation with some of our worldwide renowned magic. Here we are. Weather and climate. This amazing picture is what is called a sea of clouds, un mar de nubes en Santa Cruz de Tenerife, por cierto. So first we have to study the atmosphere. The atmosphere is the gaseous layer around the Earth. This is the atmosphere. So the atmosphere is composed mainly of nitrogen, oxygen, water vapor, and small quantities of carbon dioxide, CO2. There are a lot of gases in the atmosphere, but we need to know these four, which are the most important. Nitrogen is around 78%, oxygen around 21%, and the rest are these gases: argon, xenon, neon, hydrogen, helium, krypton. Okay, we only need to know these four: nitrogen, oxygen, water vapor, and CO2. This is the atmosphere, okay? This is the troposphere, and this is the exosphere, the outer space. So which are the layers of the atmosphere? Because the atmosphere, we can divide it in several layers. Do we need to know the characteristics of each one of them? No, just their name. Why? Because you will study that in biology. So, from closest to furthest to the Earth, we have the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. Troposfera, estratosfera, mesosfera, termosfera, y exosfera. Easy, right? The troposphere, which is the layer next to the Earth's surface, is the layer in which we live, and we live there. Life is possible there because the temperature there is suitable for living things to survive. What happens here? That the sun hits the Earth's surface and the heat is reflected back into the atmosphere. As you can see here, the sun hits the ground and some of the heat is reflected back to the space, into the atmosphere. Instead of escaping into space, the heat is absorbed by the CO2 and some other gases. Here you have them. Here the arrows are stopped. And water vapor and other gases warming the Earth. And this warming of the Earth is the reason that life is possible in the Earth. This exchange of energy is called the greenhouse effect, el efecto invernadero. Okay, you have here the diagram in which it is explained a bit more deeply. Okay, it's very easy. So, weather and climate. What is the difference between weather and climate? Let's see. Weather is the state of the atmosphere at a particular time and place, and it refers to meteorological phenomena: rain, snow, cold, warm fronts, storms, I don't know, hurricanes, typhoons, cloudy weather, whatever. For example, the weather right now here in Rivas is cloudy and cold, but the weather in other place at this same time, at this exact moment, Dios mío, can be sunny, can be warm, can be, I don't know, snowing, whatever. The weather is the state of the atmosphere at a particular place and time. For example, right now, Rivas. That is a particular place and time. What is climate, on the other hand, is the average state of the atmosphere in a particular region over a long period of time, usually 30 years. For example, the climate repeats in a cycle every year. Here in Spain, in summer every year it is very hot, and in winter every year it is very cold. Or for example, the most rainy season is the autumn and the spring here in Spain. okay, and it repeats over and over again over the past of the years. That is the climate. Okay, we have to know the difference between weather and climate. Climate in a region, on average, in a very long period of time, weather at a particular place, time and place, in an exact moment and in a specific location. Okay, here you have a diagram. The weather is are the conditions of the atmosphere over a short period of time, a minute, an hour, a day, and can change within minutes or hours. For example, on Saturday it can be rainy or stormy, and on Sunday it can be sunny. But the climate is how the atmosphere behaves over a long period of time and space. And we have average regional weather pattern over decades. For example, these are the temperatures in a specific place over a period of 30 years long. Okay, for example, in these 30 years, the temperatures are the highest value, or have the highest value in summer and the lowest value in winter. Okay, the climate repeats over in a cyclic way over a long period of time. What are the climate elements? First, the temperature, which is the measurement of the amount of heat in the environment. You measure it with a thermometer, un termómetro, and it is expressed in degrees Celsius or degrees centigrade with this symbol, okay, this little circle, and the C. Celsius is the one who invented this scale. According to the temperature, we can distinguish three climate zones in the Earth. First, the tropical zone, this one here, which is situated between the tropics and in which the average annual temperature is over 20 degrees Celsius. Then we have two temperate zones, these ones here, between the tropics and the Arctic circles or the polar circles. In these zones, the average annual temperature ranges between 0 and 20 degrees Celsius. And finally, the polar zones, here next to the poles or around the poles, between the polar cycles and the poles, in which the temperature, the average annual temperature, is below 0 degrees Celsius. This is the tropical zone, this red strip. These are the two temperate zones, the northern and the southern, and these are the polar zones. Somebody is calling me. Okay. And this is a map of the annual average temperature all over the world. As you can see, this area, this tropical zone, the average annual temperature is way higher than, for example, in the polar zones. The second element is the precipitation, which is the water contained in the clouds that falls to the Earth's surface. We measure the precipitation with a pluviometer, un pluviómetro, this, for example, also called a rain gauge, and it is shown in millimeters. Okay, you can see here the millimeters of precipitation. P. The precipitation can be in several forms. The three most common are rain, lluvia, snow, nieve, and hail, granizo. This is rain, this is hail, this is very strong hail, and this is snow. These are snowflakes and shown at the electronic microscope, which has they have these very beautiful patterns. And here you have a video of a video of the formation of these snowflakes. This is a map just as like the previous one, with the annual precipitation shown in millimeters. Okay, for example, you can see here the deserts, in which there is a very low precipitation, and the tropical areas or the equatorial areas, which a lot of precipitation in red. Then we have the atmospheric pressure, which is the weight of a column of air in a particular area. The weight of a column of air over a particular area. We measure this with a barometer, un barómetro, and it is expressed in millibars or hectopascals. The most common one is the millibars, okay? In a weather map, the lines that join equal pressure points are called isobars, isobaras. And we have to know that the normal point of pressure at sea level is 1013 millibars. So if we find an area where the point of pressure is higher than normal, so it's higher than 1013 millibars, that is called an anticyclone. If the pressure is below 1013 millibars, that area is a low pressure area, which we call depression or cyclone. And you need to know that in the anticyclones, the wind or the air moves in the northern hemisphere clockwise, like this, and in a cyclone, the air moves counterclockwise, sorry, like this. Okay, that's why in a cyclone the air goes up, and in the anticyclone the air goes down. This is an anticyclone. It is usually represented with an A in a weather map. This is a depression or cyclone, represented with a B. As you can see, the air always, in the northern hemisphere, this is Europe, rotates or moves around the anticyclone in clockwise, okay, in this direction, like this. On the other hand, in the depressions, the air moves counterclockwise. So the wind that more or less follows the pattern of the isobars, this is an isobar and this is another isobar. Here you have the values. As you can see, this is a high pressure area, an anticyclone, because the pressure around the anticyclone is over 1013, and here this is a depression because the values of the pressure in the isobars are below 1013 millibars. So here the wind more or less follows the path of the isobars. So the wind moves like this, and in a depression it moves like this. So what is the direction of the wind we can expect in, for example, in the Iberian Peninsula? Wind from the north or the northwest. Okay, from here to here. Okay, this is easy, but you have to take care of this. Next, more on another climate elements. The wind, we have talked about it just now, is the air that moves from areas of high pressure to areas of low pressure. If we look at here, the wind goes like this from areas of high pressure to areas of low pressure. Okay? We measure the speed, the wind speed, with an anemometer, which is this here, this instrument, and the direction with a weather vane. O sea, un anemómetro y una veleta. This is a weather vane and this is an anemometer. And finally, the relative humidity is the quantity of water vapor in the atmosphere, and it is measured with a hygrometer, like this, and it is measured in a percentage. Altogether, all these instruments together, the thermometer, the barometer, the hygrometer, the weather vane, the anemometer, they're usually put together in what we call a weather station, like this in the mountain, or like this in the towns or in the cities. Okay. We are done with the climate elements. We have now to study the climate factors, or what means is the things that affect the climate, the factors that affect the climate. First, the latitude of a place. You remember the latitude because what latitude is, because we studied that in Unit 1 or 2, I don't know, Unit 1. It is its location with relation to the equator. Is the distance, the angular distance of any point of Earth from the equator. And the latitude, I'm sorry, Dios mío. The latitude of a place influences temperatures. Why? Because of the angle in which the solar radiation comes to the Earth or reaches the Earth. Because the further away from the equator a region is, this is the equator more or less, the further a region is, the lower the temperatures. Why? Because the sun rays do not hit the Earth vertically, but at an oblique angle. As you can see here, this sun ray more or less hits the Earth in a perpendicular way, more or less at a 90-degree angle. Okay, so the area of radiation it's smaller, so it's more intense. But here the area is larger because the sun ray hits the Earth at an oblique angle, so it covers a larger area, but the heat is less intense. That is why the temperature is lower the further we go from the equator. Also, another climate factor is the relief, which is an important climate factor because temperature decreases with altitude. At what rate? 0.6 degrees Celsius every 100 meters of height increase, or, which is the same, 6 degrees Celsius every 1000 degrees of height increase. And at the contrary also, if the altitude decreases, the temperature raises at the same ratio. This ratio is called the thermal gradient. For example, here they have rounded it to 7 degrees, but because the real measurement is 0.65, I have rounded it to 0.6 because it's an odd number, but here they did it with 7 or 6, it depends. Well, as you can see here, at sea level we have 27 degrees centigrade. If we go up 1000 meters in altitude, the temperature decreases 6 degrees. At sea level we have, sea level means 0 meters of altitude. If it's 27 degrees centigrade at sea level, for example, at 1000 meters of altitude, the temperature decreases 6 degrees. I will make another video about this climate factor, don't worry. Then the influence of the sea, which is a dominating climate factor. Why? Because first, part of the water which forms clouds comes from the sea. So if you have more water to evaporate, you will have more clouds. And in addition, the sea becomes colder or hotter more slowly than the land. So as a result, the areas near the sea heat up in winter and cool down in summer. So the sea is like, how do you say this? It's like a thermostat for coastal areas. And this is why coastal areas are more humid and have milder temperatures than inland. Inland, in the continental areas which are far from the sea, these areas are drier and they have more extreme temperatures, for example in Madrid. Finally, the ocean currents, which we studied in Unit 3, also influence the climate, as we already studied. Hot currents favor rain and higher temperatures, while cold currents create dry and cold weather. These are the 4 climate factors. So, according to this, we can divide the Earth's climates in 3 main groups. Okay, so the temperate climates, the extreme climates, which we can also divide in hot and cold climates. The temperate climates are found between the tropics, okay, in the middle latitudes. The main types that we will study them also in the next units are Mediterranean, Oceanic, and continental or maritime. Then the hot climates, here next to the equator, are found in the tropical regions. The main types are equatorial, tropical, and desert. Finally, the cold climates are found in the polar regions, here and here in the South Pole, and also in high mountain areas. You can find this cold climate, for example, this alpine climate in every mountain which altitude is higher than 3,000 meters. Well, the main types of these cold climates are the polar and the alpine or high mountain climate. Here you have all the types of climates, all the climate types all over the world. We have the polar zones, here the temperate zones, here, and the tropical zones. And here you can find, oops, I forgot to translate this, you can find each type of climate. And this is the end. This is the Sahara Desert after a snowing day. Yes, it happens sometimes. Inverse magic in 3, 2, 1. Ok. Con esto hemos terminado la unidad 4. Espero que este vídeo os haya servido para entender un poquito mejor el tema y ya sabéis, si tenéis cualquier tipo de duda, por favor, escribidme, que es gratis, o al correo o a Aula Virtual, sobre todo, que es más sencillo. Me despido, como siempre, hacedle caso, hacedle caso a Elsa, que sabe mucho, porque para eso es la protagonista de la mejor película de Disney, Less Fortnite, More Climate. Estudiad y dejad de viciaros a juegos que además son malísimos. Muchas gracias por ver el vídeo y nos vemos en el próximo.